This is the video for lesson 4.6, and I would like you to be using a pencil, please, of course, for the note taking and any work that you do in geometry. So the lesson today, when you get done, you should be able to prove triangles congruent using ASA as well as AAS. So that stands for angle, side, angle, and angle, angle, side. So we are also going to be looking at flow proofs today. So you're going to learn two new ways to prove triangles congruent, ASA and AAS, and then we're also going to be looking at flow proofs. Now a flow proof uses arrows to show the flow of a logical argument. So up until this point we've been using statements on the left and reasons on the right. So those were called two-column proofs, and we'll still do more two-column proofs, but I just wanted to bring in the new type of proof today, which is a flow proof, and a lot of students seem to find them pretty easy to do. So the other two things that we want to look at are the angle, side, angle congruence postulate. So when two triangles are on your paper, can you prove that they're congruent? Well, if two angles and the included side, notice that the S is between the two A's this time. If the included side of one triangle is congruent to two angles and the included side of a second triangle, then the two triangles are congruent. And we're going to do some practice to take a look at that. Then we also have theorem 4.6, which says that if two angles and a non-included side of one triangle are congruent to two angles and the corresponding, remember it has to be in the same position, non-included side of a second triangle, then the two triangles are congruent. So even if that sounds like a lot of information, we're going to go ahead and practice some of these problems that have those two types of congruences in them so that you can see how they work. Now the last thing in the vocabulary section is CPCTC, and that sounds like a big bunch of letters smashed together, but I want you to remember that the phrase is this phrase here, corresponding. Corresponding means it's in the same position. Parts, that's what the P is, of congruent, that's the C, the third C, sorry, the second C, triangles are congruent. Okay, so corresponding parts of congruent triangles are congruent. And we're going to be using that in our flow proofs and in lots of proofs that we do in the future. So we're going to really want to know what CPCTC means and what it stands for. So let's take a look at the first example. It says to identify congruent triangles using ASA and AAS. So we have to remember that the congruent side has to be between the two angles to use ASA, and the side does not have to be between the two angles in AAS. So for problem A right here, it looks like we have some congruent vertical angles. So we want to keep using all the things that you used in the first semester, all your terms that you know, and that means that those two angles are congruent right there. So that looks like we have an angle, a side, because that one tick mark there is a side, and then another angle. So therefore this one shows that angle, side, angle proves these two triangles congruent. And you probably already noticed the single tick mark and the single arc on this triangle here and this triangle here. So when you have two angles with an included side, and the included side is this one that has the single tick mark on it and this one that has a single tick mark on it, then we're using angle, side, angle to show that they are congruent triangles. Now in part B, the non-included side, notice that this side that's marked congruent right here is not between. Okay, this is the side that would be between, and this is the side that would be between. So if the other side was marked congruent, that would be ASA. But this time we have an angle, and a non-included side, right? An angle, and a non-included side. So that one is going to be angle, angle, side. So those two triangles are congruent, and we can say that they are for sure congruent because there are two congruent angles and a side that's congruent, but not in between. Not in between the two angles. Now, one thing that I want to point out to you is if you see here we have a single arc, a double arc, and I could put three arcs right here because the vertical angles are congruent. We know that. However, AAA, just like AAA, maybe like your parents have as a car insurance, is not a way to prove triangles congruent. Okay, so AAA is not a way to prove triangles congruent. And as you imagine, your bottom, okay, your bottom is not a way to prove triangles congruent either. So we don't have anything that's angle, angle, side, and we don't have any congruence method that's angle, angle, angle. So just remember, we're not using cars and we're not using our bottom to prove triangles congruent. And some students, of course, try to be funny and use that as a congruence, but just make sure that you know that that really is not a way to do that. So I do have some on your own problems that I'd like you to practice. So if it's AAS or ASA, please write one of those down. And if it's neither, you can also say neither. So those are the three choices. Looking at the triangles, check and see if the side is in between the two congruent angles, it's ASA. If the side is not in between, then it's AAS. And then if it's not either of those, you can just write neither. And on the back of the first page, we have example number 2, where we're going to practice writing our first flow proof. But before we do our first flow proof, I'd like you to write a couple of notes down here in the right-hand corner of the screen. Statement goes inside the box. So if you remember from our 2-column proofs, we had a statement on the left and a reason on the right. Well, because this is set up a little bit differently, we want to put our statement inside the box and our reason under the box. Alright, and we're going to go ahead and do a practice one right now. Okay, so what we're trying to do is, it says right here in the diagram, angle G is congruent to angle B, and we can see that from what they have marked on the diagram. And side CB is parallel. Parallel, remember these little triangular marks mean that they are parallel, and they're parallel to GA. So GA is parallel to side CB, and it's important to know that because what are they trying to show us here? Well, if those two sides are parallel, then this right here is the transversal, making an angle here and an angle here congruent. Okay, and that's because of the alternate interior angles. Remember, those show that they are congruent based on the angle that is alternate interior, okay? And so you have to remember back from what we learned in the first semester in order to pick up on that. So let's take a look at what we have so far. In each triangle we have this angle and this angle over here. So I'm just writing an A because that means that it's an angle that's marked congruent. I also have this angle marked congruent and this angle marked congruent. So far in each triangle I have 2 angles. Alright, and remember from the front side, we're either going to be using angle side angle or we're going to be using angle angle side to prove the 2 triangles congruent. And that is what we're trying to do here, by the way. It says write a flow proof to show that angle GCA, triangle GCA, is congruent to triangle BAC. So whatever you're trying to prove is going to go in the last box on your flow proof. Alright, let's go ahead and put that in. And we will have to put a reason underneath here in just a moment, but let's go ahead and put in what we were given. So this information we were given, CB is parallel to side GA, and because of that, we now can write in the angles that we found congruent. Remember, we said that angle BCA in the right-hand triangle is congruent to angle GAC in the left-hand triangle. Okay, so we had these two because they were alternate interior angles. Now we have to write a reason. Underneath the box, I want you to write in the reason for that. Okay, the reason for this piece was that it was given to us up here. This one is going to be because of alternate interior angles. That's how we know that those 2 angles are congruent to each other. Now my next statement goes in the box underneath. Angle G is congruent to angle B, and of course that was because it was given to us. Underneath the box, go ahead and just write the reason in. You don't even have to put a label like reason or anything like that. Given looks fine there. And our last statement that we want to make, if you look at the diagram, remember that this side, because it's part of both triangles, is congruent to itself. So my statement is going to be CA is congruent to AC, and the reason is because of the reflexive property. Now, all of these things that you know are kind of coming together at one place. We're all looking at, things like AIA, things like reflexive. We just have to remember everything that we can possibly use to prove these two triangles congruent. So which property or which congruence did we use? Did we use angle, side, angle? Or did we use angle, angle, side? Because we need to write a reason in for our last box here. It looks like we have a side not in between the two angles. So if I go back over here to my diagram and I show you, this side would have to be the side congruent and this side would have to be the side congruent if it was going to be angle, side, angle. But it is not, because the side that's congruent is not in between the two angles that are congruent in each triangle. So this one is going to be because of angle, angle, side, where the side is not in between the angles marked congruent. Alright, I'd like you to take a look at the on your own problem. Just remember that you have to give a reason underneath each of these boxes when you're working. The information that's given is right here, so that can go in the first couple of boxes. And then what you're trying to prove, which is triangle PQS is congruent to triangle RQS, can go in the last box. And of course, you want to tell me which congruence theorem are you using, and I'll give you a couple of choices. Is it going to be ASA or is it going to be AAS? Those are the only two that I would like you to pick from. So I'm giving you quite a few hints on this one. If you just try it. You're using a pencil, I hope. So give it a good shot, and then we will take a look at it and answer any questions you might have in class. And the last page of your notes has to do with that CPCTC that we were talking about. So if you can prove that two triangles are congruent, okay, so for instance, if I can prove that these two triangles are congruent, then that means that every single one of the corresponding parts inside of the triangle on the left as well as the triangle on the right are congruent to each other. Okay, so it's saying corresponding parts of congruent triangles are congruent. So here the question is, explain how you can use the given information and congruent triangles to prove the statement. Okay, so we need to prove that C is the midpoint of BE. Well, it would only be the midpoint of BE if side BC is congruent to side CE. Alright, so let's go ahead and take a look at what we've been given, and let's mark that on the diagram. It says that side AB is parallel to side DE. So I'm going to go ahead and mark a little triangle on this side and a little triangle on this side. And then it says that AB is congruent to DE. AB is congruent to DE. And what are some other things in the diagram that you can tell are congruent? Well, right here I can tell that these angles are vertical. And we know that vertical angles are congruent, so let's go ahead and put a couple of marks on there. And the last thing that I want to mention is because side AB is parallel to DE, that makes it that this is a transversal, okay? And so therefore, we have this angle right here congruent to this angle right here. Now, it doesn't make sense to you right now, maybe the first time you see it, but you might want to start thinking about getting used to that idea, all right? They're saying that that angle or that side is parallel to that side, so where is the transversal? You want to start thinking, where is the transversal? Which angles are going to be marked congruent then? So because we have a couple of angles that are alternate interior angles, then we can say that the two triangles are congruent. So I want to tell you why though. If you look carefully, we have this angle, right? This one that I just showed you about the alternate interior angles. So we have an angle in each triangle congruent. Then we had this angle, so that's a second angle congruent. And then we had this side that they told us initially was same length. So those were congruent. So we have a side that is not in between the two angles that are congruent. This side over here would be the side that would have to be congruent, and this side right here would have to be also if we were going to use angle, side, angle. However, we do have angle, angle, side, and because the triangles are congruent, then that means that every single part of the triangles are congruent. So we've used AAS, and if we take a look at the directions here, the steps that we want to follow, mark the diagram with the given information. We did that. Add the information that you can deduce from previous geometry knowledge, which I was encouraging you to do using your AIA and also vertical angles and things like that. Decide which congruence theorem to use. We did. We picked AAS. Now, why must the two triangles be proven congruent? To prove that C is the midpoint of BE. So here's where the CPCTC comes in. If triangles are congruent, okay, so if the two triangles are congruent, then all parts, we can say all corresponding parts, but I'm just going to write in all parts are congruent, and that's where we want to say CPCTC. And we'll practice that in class a little bit as well. So explain how you know that C is the midpoint of BE, because the triangles are congruent, and therefore BC is congruent to CE, because those were the corresponding sides of each triangle. Now I would like you to take a look at the on your own problems here. It says tell which triangles you can show are congruent in order to prove the statement. So because there are only a couple of problems here, I'm going to do the first one for you. So I'll do number 5, and I'd like you to finish up with number 6. So it says to prove that JK, we're trying to prove that this side is congruent to this side. All right, now which triangles are congruent? Well, if you take a look carefully here, we have a side, an angle, and a side. All right, and which congruence postulate is that? That is called side, angle, side, when the angle that's congruent is an included angle between the sides. So which triangles are congruent? Triangle JMK is congruent to triangle LMK. Don't forget, you have to go in the same order. Make sure that J is corresponding to L, M is corresponding to M, K is corresponding to K, etc. Now, how do you know for sure that these two sides are congruent? Well, because the triangles are congruent. If the triangles are congruent, then we can say that CPCTC proves that every single part of the triangle on the left is congruent to every single part of the triangle on the right. Okay, so that's kind of a pattern that you're going to get into. You're going to say the triangles are congruent. You can tell me which postulate you used, and we have several to choose from now. We have 5 total postulates to pick from. And then how do you know that the parts that you're trying to prove are congruent? It's because of our favorite phrase, corresponding parts of congruent triangles are congruent. All right, you guys finish up with number 6, please, and then we'll answer questions that you have in class.